Hi everyone, welcome to the fifth session of our software manual testing series. In the previous session, we covered topics like the bug or defect life cycle, different types of black box and white box testing, and a few more important concepts. In this session, we are going to cover some more important questions that are frequently asked in interviews. Now, here is the first question of part 5 series. What are the different white box design techniques in STLC? The first one is statement coverage. This ensures that every line of code is executed at least once. For example, if the code has if x greater than 0 print positive, then we create a test case where x is greater than 0. So that statement gets executed. Next is branch coverage, also called decision coverage. Here we make sure all possible branches, both true and false outcomes, are tested. For example, in an if-else condition, we create test cases to cover both the if block and the else block. The third is condition coverage. This ensures that every individual condition in a decision is tested with both true and false values. For example, in if A and B, we test cases where A is true and false and B is true and false. Then comes decision/condition coverage. This combines both branch coverage and condition coverage. So we test the decision outcomes as well as the individual conditions inside them. Next is multiple condition coverage. This ensures that all possible combinations of conditions in a decision are tested. For example, in if A or B, we check all four combinations. A and B both true, A true, B false, a false B true, and both false. Then we have path coverage. This ensures every unique execution path in the program is tested at least once. It is especially useful when dealing with nested conditions and loops. Finally, loop testing. Here, loops are tested for different scenarios when they don't run at all, when they run just once, when they run multiple times, and when they run at their maximum boundary. By applying these techniques, testers can ensure maximum code coverage, uncover hidden logic errors, and make the software more reliable. Now, move on to the next question. What is defect cascading in software testing? Defect cascading occurs when one defect in the software triggers multiple other defects in different modules or functionalities. Here are the key points. One defect can lead to a chain of other defects. It increases debugging and testing effort, and it can be minimized with early detection and proper regression testing. For example, consider a defect in the login module where the system allows invalid credentials. This single defect can cascade into other modules, like showing wrong user data in the profile module, allowing unauthorized actions in the payment module, or displaying incorrect details in the order history module. So, fixing defects early is very important to prevent cascading issues across the system. Now, move on to the next question. What is defect triage meeting? A defect triage meeting is a regular session where testers, developers, project managers, and product owners review reported defects. In this meeting, the team analyzes all defects found during testing, assigns severity and priority to decide which defects are most critical, decides the next steps, fix now, defer, or reject. The main goal is to address high impact issues first to ensure software quality. Participants include QA leads, developers, project managers, and product owners. Example, if the checkout button isn't working, it's marked as high severity and high priority, meaning it must be fixed before release. Now, move on to the next question. What is critical bug? A critical bug is a defect that breaks the core functionality of your application. It's so severe that the system either crashes or blocks the user from continuing. For example, imagine you download a mobile app, but it crashes immediately after opening. That's a critical bug. Or you're on an e-commerce site and the payment gateway doesn't work at all. Again, a critical bug. These bugs are considered showstoppers because they must be fixed right away. Without resolving them, the software cannot move forward in testing or be released to customers. So, in short, critical bugs equals high severity. Immediate attention should be given. Now, move on to the next question. What is regression testing? When to apply it? It's the process of testing your software again after changes have been made, like bug fixes, new features, or code updates, to make sure that nothing else is broken. Think of it like this. You repair a leaky pipe in your house. After fixing it, you check the other taps and connections too, just to ensure your repair didn't cause new problems. That's regression testing in software. When do we apply it? After bug fixes, after new features are added, after performance or code improvements, and especially before any release to confirm the system is stable. This image is for regression testing approaches using simple block diagram. The first one is retest all. Here, we re-execute all existing test cases to make sure nothing is broken after a change. Advantage, maximum coverage. Disadvantage, very time consuming and expensive. The second approach is regression test selection. Instead of running every test case, we select only those test cases that are impacted by the recent code changes. Advantage, saves time and effort. Disadvantage, needs good analysis to pick the right tests. The third approach is test case prioritization. Here we run the most important test cases first, like critical business flows or high risk areas, before running others. Advantage, ensures quick feedback on high priority features. Disadvantage, lower priority cases may get delayed. So, in summary, retest all equals maximum coverage but costly. Regression test selection equals only selected test cases faster. Prioritization of test cases equals runs high priority tests first for quicker feedback. That's how teams choose the right regression testing approach depending on time, cost, and project needs. In short, regression testing equals rechecking old features after changes to avoid unexpected failures. Now, here is the next question. What is test harness? A test harness is basically a collection of software and test data used to test a program unit under different conditions like stress, load, or data driven scenarios while monitoring its behavior and outputs. Think of it like a testing framework. It provides the environment, the inputs, and the controls to check how the software behaves. A test harness mainly has two parts: test execution engine, which actually runs the tests and manages execution; test script repository, where all the test scripts and data are stored for reuse. In short, a test harness helps automate testing, monitor results, and ensure software works correctly under different conditions. Now, here is the next question. Explain requirement traceability matrix. A requirement traceability matrix is a document that links requirements to their corresponding test cases. It ensures that every requirement in the project is tested and verified. For example, if your project has a login requirement, the RTM will show which test cases cover that login functionality. If there's a payment requirement, the RTM ensures test cases are written and mapped for it too. Why is it important? It makes sure no requirement is left untested. It helps in impact analysis when requirements change, and it provides full visibility and coverage to clients and stakeholders. In short, RTM equals a checklist that connects requirements with test cases, ensuring complete coverage. Let's discuss regarding this RTM image now. In this table, we have different requirements like user registration, product search, add to cart, and payment integration. Each requirement is tracked across different stages: design, development, testing, and deployment. For example, the user registration requirement is still in the design stage. Development hasn't started yet, but the test case T001 has already been mapped. The product search and filtering requirement has its design completed, development in progress, and linked to test case T002. The add to cart requirement is more advanced. Design and development are complete, and testing with T003 is ongoing. Finally, payment integration is still in early stages with design in progress and development yet to start. What does this show us? This RTM provides end to end visibility. It tells us the status of every requirement and ensures that each requirement has a corresponding test case, so nothing is missed before deployment. Now, move on to the next question. What is test closure? It's the final phase in the testing process where all testing activities are wrapped up and formally documented. For example, once all test cases are executed, defects are fixed or deferred, and reports are prepared, the testing team prepares a test closure report. This report shows what was tested, how many bugs were found, how many were fixed, and the overall quality of the product. Why is test closure important? It confirms that the planned testing is complete. It ensures all critical defects are addressed. It provides test metrics and insights for future projects, and it marks the official end of the testing cycle for that release. In short, test closure equals finishing, reporting, and learning from the testing process. All right, that brings us to the end of part 5 in our series. In this session, we covered some important questions and concepts in software testing. In the next part, we'll continue with more interesting and important topics that will further strengthen your understanding of testing. I hope all the concepts we discussed so far are clear to you. Keep revising, keep practicing, and I'll see you in the next session. Please comment below if you have any questions or need any clarifications. For mock interviews or online classes, you can contact us at the email ID provided. Send us an email with your contact details and we will get in touch with you. Don't forget to follow and subscribe to Tech Margadarshi for upcoming videos. Thank you and happy learning.